Good morning and welcome, my dear children. Now we are going to do one or two questions from electrostatics second year. Now, as you see, the purpose of this program, not to teach a problem, but to see how the principles or concept in physics were employed in each problem. As you see, each chapter contains or consists of limited number of concepts, and based on that we can frame any number of questions. Now here we are going to discuss a question previously asked, and the question is this one: a parallel plate capacitor is a dielectric slab of dielectric constant K between the plates that covers 1/3 of area of the plate. You can see that on the picture as shown in figure. The total capacitance of the capacitor is C, while total capacity means the arrangement which is partially filled up as shown in figure. The total capacitance of the capacitance is C, while that of the portion with the dielectric constant is C1. When the capacitor is charged, the plate area covered by the dielectric gets charges Q1 and the rest of the area get charged Q2. The electric field in the dielectric is E1 and that in other portion is E2. Choose the correct options, ignoring the edge effect. With a multiple option question. Therefore, we have to analyze all the options and see which one is correct and which one is wrong, and investigate the answer. After all, this is a problem associated with the capacitor. And in the problems, it is said that C is the capacity of the total capacity of the arrangement. But as you see, it is partially filled as in figure. If we draw, now this arrangement like this is A by 3 area of this part, and this is equal to 2 by 3A area of this part. This is filled with the dielectric, and dielectric constant there is equal to K. Here 1/3 is filled with the dielectric, and this is air core capacitor. And again it said that the dielectric charge in the problem, it said that when the capacitor is charged, the plate area covered by the dielectric, the charge is equal to Q1. Over here the charge is equal to Q1 and the rest of the area gets charged Q2. And electric field in the dielectric is E1. Here the electric field intensity is equal to E1. And that in the other portion is equal to E2. Choose the correct options. One more thing we have to introduce. Suppose sigma 1 is the charge density here. Sigma 2 is the charge density here. Even though it is not there, we are going to say that sigma 1 is the charge density there, sigma 2 is the charge density here. Now E1 by E2, first of all we have to find E1 by E2. The electric field intensity ratio in these two regions, here and here. You see, this plate is the same, and therefore we can say along that plate, since it is a conductor, the potential everywhere must be the same. Therefore, the potential here, everywhere is the same because it is a conductor. Otherwise, it will violate the basic principle. That means there will be automatic current. But that is not there. Upper potential everywhere is the same on this plate. Similarly, this plate, again since it is the same, the potential here some other value but remain the same. So this is of constant potential and this is another one, another constant potential. And therefore, what about the potential difference between these two? Potential difference matter, maybe the material that is filled there, we are not bothered. The potential difference between that two plates must remain the same. So PD between the plate here, it is V, this is V. V is the potential difference. And here or here or here, it remains the same. If potential difference is the same, then you know what is the electric field intensity, PD by unit separation. And that if you write down, definitely be the same for, because separation between these two is the same D. PD per unit length is called the electric field intensity. And that is same here and here, is equal to V by D. And that remains same. And that remains the same means E1 by E2 is equal to 1. So this option is correct. E1 by E2 is equal to 1. And at once this option is wrong. Next one. Since electric field is the same, we have to write down what is the expression for E1. The electric field intensity E1 is given by E1 is equal to, since it is dielectric field, sigma 1, where sigma 1 is the charge density of the plate there. Now we are considering only this plate, this capacitor. Electric field intensity is given by E1 is equal to sigma 1 by sigma by epsilon 0, epsilon r here is equal to K. And what is the electric field intensity here? E2 is equal to, again, charge density here sigma 2 by, and there is no dielectric, there is air core capacity is equal to epsilon 0. Since E1 by E2 is equal to 1, dividing these two. So E1 by E2, if you do, 1 by E2 is equal to sigma 1 by epsilon 0 K by sigma 2 by epsilon 0. So this will cancel out. So it's equal to sigma 1 by sigma 2 into K. So E1 by E2 is equal to sigma 1 by sigma 2 by K. But E1 by E2 already we told is equal to 1, and therefore this is equal to 1. If this is equal to 1, then what is sigma 1 by sigma 2? Sigma 1 by sigma 2 is equal to, sigma 1 by sigma 2 is equal to K. If that was the option there, sigma 1 by sigma 2 is equal to K, that is correct. If that option is not there, if it were there, then that is correct. But here it is not there. Idum namakku problem, or you can give or consider as an option. Sigma 1 by sigma 2 in this problem is K. And if it were there, it will be correct. Next, once you obtain sigma 1 and sigma 2, we can calculate Q1 and Q2. What is Q1? Q1 is given by, Q1 is given by sigma 1 by sigma 2. Then next one that we have to find Q1 and Q2. Q1 is sigma 1 into area of that plate. But Q1 is equal to, Q1 is equal to sigma 1 into A by 3. Q2 is equal to charge density of that plate, sigma 2, into area of that plate, 2 by 3A. Therefore, Q1 by Q2, if you do, Q1 by Q2 is equal to, Q1 by Q2 is equal to, you will obtain sigma 1 by A by 3 common cancel out is equal to sigma 2 into 2. But sigma 1 by sigma 2 already you got. Sigma 1 by sigma 2 is equal to K. That is sigma 1 by sigma 2 removed by K, you obtain the is equal to K by 2. Now Q1 by Q2 is equal to K by 2, but here there is equal to 3 by K. That is wrong. Therefore, this option is wrong. This option is correct. This option was wrong. Now, next thing we have to find capacity. See, on the entire arrangement, also the capacity of the upper part. Entire arrangement, if you look, you can say, you can consider this one is a capacitor and this one is another capacitor. They are connected in parallel. About C1 if, no. You can say C2 is the capacity of the upper part and C3 is the, C1 is the capacity of the upper part. So with C3 is the capacity of the second part. Then they are arranged in parallel to get C. Therefore, we have to get what is the value of C1 first. C1 is the capacity of the first capacitor, C1. Or it is fully filled with the dielectric and the concept epsilon 0 K A by 3. Separation between the capacity. This is C1. And what is C3? The capacity of this part. C3 is equal to, then air filled capacitor is equal to epsilon 0 2 by 3 A by D. Now, here epsilon 0 A by 3D, epsilon 0, this is our C3. Then, now these two capacitors are arranged in parallel. Or now you can replace C3 or we can represent C3 in terms of C1. Now for which you know that epsilon 0 A by 3D, epsilon 0 A by 3D, epsilon 0 A by 3D. That is the string. Epsilon 0 A by 3D here also. Is equal to C1 by K. Is equal to C1 by K. C3 is equal to, you can write like this. Epsilon 0 A by 3 is equal to C1 by K. 2 into, what here 2 is there? 2 into epsilon 0 A by 3 into D. Epsilon 0 A by 3 into D C1 by K. C1 by K. So C3 is equal to 2 by K C1. Then what is C? C is equal to C1 plus C3 because they are parallel like this. These and these are arranged in parallel. And therefore effective capacity is equal to C1 plus C3. That is equal to C1 plus 2C1 by K is equal to C1 into K plus 2 by K. C1 into K plus 2 by K. That is our C. And what is the question of C by C1? So C by C1 is equal to K plus 2 by K. And you can see that that option is here. And therefore both A and D, these two options are correct. Now you see, when multiple questions are there, you have to verify all the options. All the options. Therefore it consumes more time than other questions. All options check in. One more option we can introduce there during our discussion that you found, sigma 1 by sigma 2 is equal to K. That can be included in the options. Okay. Now this finishes this question.